All right, everybody, thanks for joining us. It's now noon Eastern time, and welcome to this Lunch and Learn webinar brought to you by the Waterways Committee from COPRI. Today's topic is water injection dredging in U.S. ports, and Joe Wagner, the Senior Dredging Engineer from HDR, is going to go ahead and lead that topic. I want to go ahead and pass it over to Joe, and thank you again for joining us.
Hi, folks. So I'm coming to you here from the Jacksonville district area in Jacksonville, Florida. Couple of decades of experience doing dredge material management. A lot of work lately on trying to increase dredging efficiencies, driving the train to try to do this, this technology that sometimes feels like we're still stuck in the days of the Egyptian Nile. Driving it forward to get as much efficiencies out of it as possible, and to try to do things with natural forces and things that just kind of make more sense. So this will kind of focus in on the dredging technology itself specifically, but I do want to give a little bit of background to kind of give context to this. So we'll jump in and talk a little bit about traditional dredging methods, what they specifically require, what they inhabit. Then talk about hydrodynamic dredging in full. There's more than just water injection dredging that fits under that category. Then we'll look at two case studies. One, there is a dredge working in the U.S. that's active. We're going to be doing some monitoring on it coming up here soon. And the other one is one just about to kick off. To kind of summarize things with some data and statistics at that point, and then open up the discussion. And I'm hoping to have plenty of time at the end for discussion. There are several ports we've talked to, different facilities we talked to, and they may be of interest to you, and we'll bring them up as we come. So traditional dredging. What you see here are the four most common types of dredges out there. 3 out of the 4 require hydraulic dredging, and hydraulic dredging means that there's a pipeline somehow. That pipeline is entraining the sediment, and that pumps pipeline transport of the slurry is being taken to some kind of disposal location, and that may be multiple booster pumps added to it for the miles that it goes, and so forth. So that's traditional dredging. An example of a traditional dredge, this is a hydraulic dredge. The right end of the beast you see there is the business end of the beast, and it's coming down to cut into the surface. Of interest, you'll notice that the cutter head doesn't really spin that rapidly. I think a lot of people think it's sort of an egg beater. Material goes through the pipeline, through the pump, and then gets pushed out to a disposal location of some sort. Of interest is how these things actually move. Most of them move by anchors and spuds, and they cut in these arcs. I think understanding and appreciating how that actually happens. These aren't easy things to work for half of a channel. They're not as easy to work in confined locations because of the way that they do their movement. So that's the hydraulic dredge. And in it, you're pumping 9 to 10 times as much water as you are actual sediment. So it really is about water in this case. In terms of mechanical dredging, well, you're really just talking about the earth moving dredge, the earth moving that people are used to. As you can see, when the dredge head starts in the water, it instantaneously will start some turbidity. And then as it impacts the surface, in general, there's actually even more turbidity than it's being shown here. As it comes up, material is lost at the side, turbid flow happens. So there's a lot of sediment that comes in and out of that bucket that also gets dispersed. And because it's not on an earth moving situation, it gets dispersed in the water column. These also generally move by spuds or anchors. This is a huge system right here. The bucket you were seeing there was roughly 50 cubic yards, which is, I don't know, 20, two dump trucks. It might be a good way of thinking of it. Okay, so that's traditional dredging. Now for something completely different. Hydrodynamic dredging is the least used dredging method in the United States. By sure, and it is somewhat used more often in Europe. It's still no more than 10 to 15% of the maintenance dredging. The most of that dredging is done in these locations where it's used. But it is, it has its niche. It's much more environmentally friendly in a lot of ways, and it works with natural systems, which can be a big benefit when we're looking at the dredging techniques out there. So, divide and conquer. What we talked about originally are hydraulic, mechanical dredges, the traditional dredges, and they're as much about the transport of the sediment through some sort of pipeline, barge, bucket, hopper. Something is happening to move that sediment, and that is a big portion of the cost in a dredging project. Meanwhile, hydrodynamic dredge is all about material moving through the flow of water. You're not carrying it in a bucket, you're not carrying it in a hopper, there isn't a pipeline involved. It is the free flow of material through this water column. So, drilling down a little bit more into hydrodynamic dredges, there's basically two families, two groups. Agitation and plow dredging are the kind of the brute force, inelegant, get it done kind of methodology. So the whole water column is going to experience this sediments coming up. The whole water column is going to be part of the action of the movement. Instead, in contrast, the water injection dredge is creating this density current. And this density current, and we'll show some demonstrations of it coming up, stays close to the bed, doesn't disturb it through the whole water column. We're looking at this dredging technique in a couple of reservoirs for those very purposes, because the different turbidity function that happens here. So that's the big thing to think about these two families of hydrodynamic dredges. So a little bit more on the hydrodynamic agitation and plow dredging. All hydrodynamic dredging requires two things. Something has to bring the material into the water column at some height, some extent. It has to stir the material, has to resuspend the material. It has to, in the water injection case, fluidize the material. Then you have to have some kind of current force or something that is going to act upon that material and carry it out. And a lot of us, you just don't think about this. There's a lot of material flowing down any river system, any coastal estuary and bay at all times. And we don't really think about how that could be used to our benefit in terms of these dredging techniques. So, it's not something that's used a lot in the US. So you think of it sort of as prop wash. A hopper dredge that would fill and overflow used to be a technique that was used pretty often to do this very same thing. Vertical mixers, air bubblers, SEDCON systems. Some port systems have these things they call SEDCON systems, or siltation prevention devices. They fall in this kind of hydrodynamic dredging, agitation and plow category. And then literally the plows, the rakes, the beams, and so forth. And again, you will see the water resuspend sediments. This is a picture of a dredge right here resuspending some of the sediments by agitation. It is a visible plume. Now, that doesn't mean that this isn't something that can't be used. It needs to be used in the right circumstances. And as a matter of fact, it's being used in a big way in the Netherlands and a couple of other places. The first one you see here pictured is the mud motor over on your left. What was happening is material would be removed from the port, the basin, taken offshore a great distance because it was rather shallow in this area, then released onto an offshore kind of disposal location. A lot of cost in that movement of material. But even more importantly, there was a loss of that material in the natural system. And they were finding out that they were basically starving some of their estuaries by taking this material off. Those folks out there who are thinking of how this might fit in the US, Louisiana, and the loss of all that marsh out there is kind of a good example of this, that we basically starved a lot of these systems by handling this material and taking it out. So what they do now is they're taking the material out, they're bringing it close to shore where the mudflats areas are reasonably close, and then they're releasing the material to flow in with the tides and basically mimicking the natural process. It's cheaper, they don't have to worry about the location of the material, and they get the added benefits environmentally. Similarly, can be done with sand. What you're seeing here with the sand engine, instead of mobilizing 5, 6, 7 times on a large beach project, they burden the material onto what would have been the natural template, and then let natural forces, the agitation, the movement of waves, to carry that material in a more natural way. cheaper again. You're doing less mobilizations, demobilizations. More environmentally friendly. It happens at more of the pace. When you go out there and do a beach renourishment job, right, it's rather intrusive to the natural environment there. So this helps break that down and slow that down. So now on to the water injection dredge. And this is the specific dredge we'll be spending most of the time talking about. There are several types of water injection dredges out there, but this is the one that was purpose-built, brought from the Netherlands. IHC is the designer. It was built in the US, and we'll talk about why they have to be built in the US. Interesting part of the system here, you'll see this open pipe. That's because the pipe is laying down on the side that actually brings the water in. It just barely lays down below the water surface here. You can see that it's very close. It's a very shallow barge. The beam, the reach of the jet bar goes down to 50 feet because that's the depth of which North Carolina works. And we'll talk more specifically about the details of this dredge. So what do water injection dredges do? You'll see pictures of the nozzles in action and a couple of different examples, but you have to remember that that's happening at the water surface. It's, excuse me, not the water surface, but at the base surface of the river, the reservoir, and the water body. It's not happening above water. It's happening very close to the surface, and it actually will happen at less pressure than you'll see it when they're demonstrating it. So it's about getting a high volume of water in at low pressure. And the reason you're doing that, again, is you want to fluidize the sediment. The whole purpose is to make this density current. It's not just to pick up the sediment off the bottom. So once that density current is created, it stays close to the bottom because it has the forces of the water above it, especially when you're dealing with a port like North Carolina, where you're almost at 50-foot depths. So what does that density current need to move it along? Well, it needs either tides, which is what North Carolina is mostly using. Could be currents. There's several ports and systems where the currents are strong and unidirectional, that just getting the material into that current would be very effective. Gravity, when we talked about the reservoirs we talked about earlier, gravity might be a key way to get that material to flow through those reservoirs. And then just any other hydrodynamic forces that might happen out there. But it has to be something that's well understood, and we'll be talking about that a lot when we get further in there. So now a demonstration of what a density current looks like. And you have to picture that this is at scale. That would be 50 foot of water. The current height that you would see would normally be, say, 3 feet at the most to 4 feet under this 50 foot of water. So it's a very unobtrusive system that you're seeing happen here. And once the material is in this current, density current, it will travel a good distance depending on the type of material. So the geotechnical understanding of the material out there is going to be really important. The next video is from Van Ord. All the stuff that's around this section of the video is all advertisement for them. So I've cut it down to just really look at the dredge itself. And this also helps because it gives you another view of what another dredge could look like for a water injection dredge. So we'll start the video. Really doesn't take a lot of operation, in terms of crew. It's a singular unit. It pushes out the material like you're seeing here, and there's the unidirectional flow of the current there. Just a second, you'll see the jet bar at the left end there. You'll see them turn it on in a little bit and see the nozzle flow. So that's, again, a lot of volume of water, but not at a high pressure. And you're dealing with only water pumps. You're not dealing with dredge pumps. So these are much simpler systems to maintain. In the cab of this system, and this one here is really basically almost an ocean-going capable system. This is quite a bit more industrial than what North Carolina is using. They have the survey. They know exactly where they are. They know how far down to put the nozzle. They know what the cut template is. They know how far they need to go. And really all you have to do is renew that hydrographic survey each time to know when you're coming back to an area and what you need to move the material. So he's creating the current in this case. Current's going to reach this open flow and be dispersed out. You'll notice that he isn't moving very fast. They move basically a knot and a half at the most is really tremendous if they're doing that much. That doesn't sound like a lot until you realize there is no dredge out there that's moving a mile in an hour. You don't do it hydraulically, you won't be doing that mechanically. So it is really pretty rapid, but it's just a comparison that you have to think about in terms of other dredging techniques. So with any dredging technique, with every dredging technique, there has to be some environmental considerations. Contaminants being resuspended. Using this in the Kalamazoo River is not going to be an efficient and effective way to handle the material and the portions of the Kalamazoo that they're concerned about, for example. Suspended solid effects, if that's a big issue in the waterway, and understanding what that level has to be, that may be something that prohibits this. And just other site-specific impacts. So there are definitely considerations to be made when you're looking at using this dredge. The biggest thing is to understand the general destination of the dredge sediments. And we'll talk a lot about North Carolina here and what the U.S. Army Corps Verdict Group is planning to do to help with some of that and their usage coming up in a little bit. One of the things that doesn't get enough mention here is the ecological advantage of using this for sediment distribution within the water body balance. You basically are doing the things that are natural, the storm, picking up material and carrying it by, extra high currents, a tidal cycle. You're mimicking all those things, and those are things that the infauna and things have adapted to and can find a way to react to. So that's one of those things that just doesn't get enough discussion about how this actually mimics a more natural situation. Again, talked about the sediments needing to be analyzed, needs to be understood. In most cases, people don't realize, but the sediments that are on the bottom of your river and the sediments at the bottom of the port berth are not very much different. And there usually is not a huge constraint on moving maintenance material out of a basin like this. So environmentally, there's basically a checklist. We need to do soil characterizations, understand the site bathymetry and geometry. Are we sending the material in a place that it's going to be beneficial? Hydrodynamic conditions, the geographic location that you're working in, type and level of contamination, and then regulatory agency acceptance. And that's a key, of course, to any of these kind of projects. So let's briefly talk economic benefits. When you're seeing one of those hydraulic dredges out there in the plants and something be able to reach down and move sediments at 50 feet of water, you're talking a $12, $15 million dredge itself. Then there's the pipelines, the boosters, the disposal locations. There are a lot of pieces to one of those productions. Instead of the hydrodynamic dredge, you're buying one unit. The North Carolina dredge was basically a $3 million dredge. You compare that in the cost of the plant for one of these other dredges, and you get a real quick understanding that just the cost of the equipment is a big generator of the difference of these two operations. Same for disposal areas and storage areas or beneficial use areas. There's a lot of added costs that don't get calibrated, don't get put into the picture of understanding what maintenance dredging costs and what the actual bottom lines are. And they are very expensive. And there's lots of ports out there with a lot of material in their CDFs and already in their confined disposal areas, and they're pressed to try to find more capacity, and it's not going to be cheap. So, comparing and contrasting the economic benefits, your demobilization is a really good one. North Carolina literally will have the dredge at port. It's there, it's moored. If they need to use it when it's during their time for environmental window, they can take it out and use it. They can use it. There isn't bringing a contractor in. There isn't setting up all the pipeline. There isn't all the other things involved in a production for some of these hydraulic or mechanical dredges. Transportation and storage of material. You don't require these disposal facilities, and we'll talk about them a little bit. Very expensive component of dredging. It's a simple O&M system. The most complicated thing on these things are the nozzles, being able to direct them and how to handle flow on those, and we'll talk a little bit about that. And really, it's a water pump. This is standard type of equipment that's on there. Not the same as a dredge pump that actually entrains the material inside, has great wear and tear and expensive cost for those, and a higher production rate. And we'll talk about that extensively as we go forward. So, trying to put all of this into a picture. On the graphs over there on the upper left, what you're seeing is the amount of dredging from 1963 through 2020 US wide, and you can see a decreasing trend in the volume that has been dredged. So all four of those categories are listed, are types of dredging from those years, 63 to 2020. And you can see an overall decrease. It may feel like we're doing a lot more dredging out there, but in large, we're actually decreasing. And it's roughly decreasing about 4 times the commitment what the Corps had back in the 60s to what they have now. And for industry, it's about a 25% decrease. So overall, we're doing about 70% of the dredging that was done. At that same slide, if you look at it, same graph, new work has decreased roughly a 1/7. It may feel like we're out there and dredging a lot of new docks with all the deepenings that we're seeing out there in ports and so forth, but in large part that has decreased dramatically. But just to balance that, the amount of maintenance dredging has increased by 21%. So there's there's an increase in what is new dredging and what is just being done to maintain things. Even after, and now looking at the cost slides, even after taking inflation into impact here, if you take and balance these numbers based by inflation criteria from 60 to 2020, the U.S. Corps has almost doubled in the terms of the cost for their dredging. Meanwhile, industry has increased by more than 150% in the overall cost of dredging. So significant increase in the cost of dredging in itself. But again, because we're talking about a technique that really deals with maintenance dredging, I wanted to drill down into that. The U.S. maintenance dredging responsibility is basically shifted from a Corps responsibility to more of an industry port responsibility. And the Corps' portion of that is decreased from the 60s to now by about 17%. But now it's industry's responsibility, roughly about 75%. So this, it's a lot of information. But the bottom line is it's getting more expensive. Ports and harbors are being required to do much more of it, and it is mostly maintenance dredging. So some technique that helps us with that is going to be very beneficial. All right, so let's look at the case study. Let's look at what North Carolina did. So North Carolina has 2 ports, and that's going to be important because one of the things they want this dredge to be able to do is be able to work at both ports. So they'll analyze both port situations, and they'll analyze also transporting between both ports. I got involved with them in 2016-ish, roughly, when we were looking at a turning basin deepening project. And at that time, they had already in 10, 15, 20 years of lamenting where are they going to put the next big batch of sediment. They knew they wanted a deepening program to happen. They wanted things to come forward. They were going to have to find a lot of capacity very quickly. Understanding the situation of the system out there. So as we zoom in, the area that feeds the Cape Fear River, which runs right by the port, is basically about 9,000 square miles. It is heavy siltation river, flows down. There's your main port facility. And when you find one of these main port facilities, you're almost always going to be finding a cell of dredge material next to it. In that case, it's one stacked basically 45 feet high. They believe they can go as high as 65 feet. The cost to raise these dikes is enormous, let alone all the other things that are involved. And almost any time you look at a slide in North Carolina, you'll find a dredge out there working in the general area. And it makes sense. As the material is flowing down the river, you suddenly get to this port facility, which is wider and much deeper than the area where the material has been coming. It has suddenly a place to settle out, and there it settles out in front of the port. But not only does it settle out in front of the port and the channel and the turning basins in the center, but it settles out on the edges, which is another encumbrance for a port. Their berths have these material wants to pile up. It ends up to be one of the quietest area for the material to kind of find its way and suspended and deposit. So that was a real big point of the North Carolina project, was able to get in there and remove this material right close to the berths. So roughly spring of 2018, we got into getting more data for North Carolina, letting them understand what the picture is out there. So we talked to roughly 20 organizations. We talked to everybody I could think of, and I'm sure some of you are out there, the people that I contacted. We were trying to get base information on, what the water injection market might be out there. Is it a capability? Is it a possibility? Are there contractors interested in doing this just yet, and all that? So there was a big push to give North Carolina some data. Once that was determined, and we had a group of folks that seemed really interested in bringing this technology to the U.S., we then moved on to the next step. And here's that caution I brought up earlier, the Jones Act. So vessels have to not only be flagged in the U.S., but they have to be built in the U.S. based on the Jones Act. So that was going to be part of the deal here. We weren't going to be able to just go to Europe and, like you buy a crane and bring it over and use it. You're going to have to build this in the U.S. So, there isn't a contractor necessarily unit set up that wants to do this on their own. There isn't yet the dredges available to just buy off the shelf. So the port saw that they were going to very quickly have to do a design build, which they were comfortable with. So a procurement fact sheet was created. We basically said, here is the requirements we're going to need. Here are the general things you'd expect if you're buying any piece of equipment for a port. We're going to expect those things from you, but we're also going to expect some other things because it's the first of its kind. We're going to want a proof of concept. We're going to want you to come out there and use that dredge at the port and to actually operate it for a while and demonstrate that it is effective and works. We're going to set the criteria. You're going to have to meet that criteria. There was also going to be a training component of that. The port wanted to use its own facility staff, which really ends up being one captain and two folks who rotate on and off of that dredge. They wanted them trained so that they would be responsible for that. And they wanted that training technique to match where they could, tweak it as they go. So they wanted it to be kind of interactive. So we got that information out there, got a really great response. So we sent out a request for pre-qualifications, and the figure you see here was actually one of the model dredges, which ended up being the one that was selected. We would get this kind of information back, some of the details about the propulsion, why they figured it would be sufficient, what would the jet bar depth and reach be, how easy is it to turn the nozzles on and off, all those sort of things. So once that was happened, they pre-qualified the dredgers that we'd be doing, and then they asked at the same time when they were pre-qualified to then also give in a detailed bid, cost bid. If they didn't reach the pre-qualifications, if they weren't acceptable, they weren't going to open the bid. And that way, because states have to work under different contracting requirements, that allowed them to do that and allowed them to kind of buy an investment in with the contractors. They even at one time proposed possibly putting a stipend in so that there would be a little further in the design, but they realized or felt that they realized it wasn't necessary. They were getting enough folks interested and they saw the market, but they didn't do that. But that's another option as well. So while that whole process was going on, one of the interesting things that happened is the feedback was the geotech you have isn't sufficient. And they had a lot of geotech. They had done a lot of wharf strengthening. They had things from center of the channel. But all the geotech we normally collect in a port situation is looking for hardness and firmness of materials, talking about blow counts. Well, what you need with the water injection dredge, you need to understand if that sediment will shear. You need to know, what is the ability for it to split apart and go from a solid mass into a fluid mass, right? So there's a different set of requirements that you want to know and do. So we did a basic geotechnical investigation for that. We did over 25, 30 borings. I can't remember the exact number, but quite a few. Pretty inexpensively. It was $60,000 total for both ports, but it was enough information that the folks designing this could say, okay, yeah, this is the pressures that will work. This is the amount of water we'll need to get in there and agitate the material to cause it to fluidize. So design build RFP goes out. Technical proposal and the seal price, as I mentioned before. Each team comes in, does a presentation. There's a matrix, basically evaluate. And interestingly enough, the least cost alternative was not the selected dredge. They looked at everything involved with the whole process. Again, remember, they're buying a partner to help them with the training and that sort of thing. So they looked at doing it with more of this kind of unit. So it's a singular unit together, as opposed to this kind of unit, which would be something on a barge and then a tug or something, whatever was available at the port, can move the material around. And they really, you know, a lot of it was based that they wanted to be able to go between those two ports. And they felt that if the system was one piece and it was by itself, literally they're going to, you know, crank it up to 6 knots with the propulsion and take it from one port to the other, basically an overnight trip. That seemed to them to be more reasonable. This kind of system, and this may be the solution for others, literally the barge could be broken up into pieces and put on container trucks, and you could take it quite a distance, rail or car, you know, any of those were available to you. The port didn't want to be in the process of having to put this thing together back and forth all the time. They felt the wear and tear of that would be partly disadvantageous to them. They wanted to, they liked the system where it was one unit. So here's the dredging question. It's called the Osprey. Anybody familiar with Wilmington will know the university there's mascot is the Osprey. It's really where that came from. The obligatory champagne blast. So you're looking at the back end of the system. You see the propulsion, not really, you know, not a heavy duty thing that's necessary. You're really just moving a barge. You'll see the jet bar down there. You'll see the nozzles, and it's an array of nozzles on the sides as well as in the center. They've got it turned on full blast to demonstrate the nozzles work. They can crank some of them down, some of them up, and they tend to, when they're using it, they crank the ones up closer to where the berths are, where the material kind of piles up at an angle. So they end up focusing more on that material when they come through. And then an overlook of the system. Again, you know, roughly, it was under $3 million for the whole system for the purchase. And then, because this is a shipyards video, we zoom out to see a pretty picture of the shipyards. Move on from there. So they use that dredge. You know, this is all happening during the pandemic COVID situation. They used that dredge last year during their window. They have an environmental window where they're allowed to use the dredge, and other times they're not. And I'd be glad to discuss that if it's a question people are interested in. And unfortunately, they had planned to do that with monitoring by the U.S. Army Corps, ERDIC's division, but that did not happen. But it is planned to happen this January. So the U.S. Army Corps at ERDIC, they've created the plan already. It's funded. They're planning to be out there in January. The first thing they're going to do is compare pre and post dredging hydrographic surveys, not just at the site, but further down the stream, and see where the material goes and how they can account for it. North Carolina's permit currently requires them to dredge 1,000 feet upstream and 2,000 feet downstream of the dredge. They have never been able to locate any, what word am I looking for? Any buildup of material there during that process, because for a lot of reasons, spatially, imagine that you're taking something from a berth may be as long as 1,000 feet, and you're fluidizing it and sending it out, and then you're looking for it over 2.5 miles. You know, if you consider 1,000 feet, well, 3,000 feet, you're basically looking over that area. It appears that it disperses well enough that it disperses well past that. So this investigation one of the things that we'll do, we'll look at pre and post bathymetric surveys to establish with that. They will look at the production rate of the dredge. North Carolina has confirmed that the production rates well exceed the standard we had set, but they're not really wanting to put something out there until the third party like the Corps comes out there and takes a look at it. And I think that's a reasonable thing to do. It'll also, which I think is really important, technologies like this, you need to tweak them. You need to figure out the efficiencies. You need to figure out things you can do that help the system. They'll help them set a production standard, and then they can try various things when they're out there to see how they might improve. So right now they come out right before the peak of high tide, crank the thing up and work the area. Well, what if they came out a half hour before that? Would it help? What if they waited and came back a half hour after that? What if instead of paying attention with the tide right at the berth, they were looking at the undercurrent flow? The flows on the bottom of a river are slightly different, even with tidal cycles, than they are going to be, you know, in one place or another. So there are a lot of components that might be in there where they can tweak and improve their system. So they're very much looking forward to getting this feedback and understanding how that might work. And then there's sort of a list of equipment that the Corps is planning to use. I will say that the Corps is very excited about this. and they would like to have another opportunity to possibly do it at other ports as well, and see the systems in different configurations under different conditions. And so there are talks with manufacturers out there that might produce one of these, who might produce, say, a prototype that could be taken to a port or facility and tried out, see how well it might work. And then, there's some actual data to go with it. Once that data is there, they can make the decision if they wanted to move forward or purchase or what have you. So now the second case study I wanted to jump in some detail, but like I said, I'd be glad to talk about any of the other case studies or any of the other information, or just any general site. And that's the Port of Tampa Bay. Port of Tampa Bay is one of the largest container and cruise terminals in the U.S., and I think a lot of you are very familiar with it. It is an immense system. There are, roughly 10 miles of channel outside of the estuary, and if you're going to try to find the ODMDS disposal area, you'd have to go off this picture another 9 miles. So just taking materials to an ODMDS takes them 20 miles one way, 40-mile round trip. And that's very expensive, obviously, in these kinds of conditions. Also, one of the interesting things about Tampa is each and every one of their main stem channels really are fed by stormwater. They all come into a city system where it is basically the outfall of the city stormwater on the way into the basin. So, they are dealing with that water, those sediments, those criteria, as much as they do with what's happening within the ocean, the estuarine system. Another thing that's interesting to see in this picture and realize, so these are their confined disposal areas, their main two, and they do also have some upstream here as well. And that's MacDill Air Force Base. Just to give you an idea of how huge these CDFs are. That is one of the largest Air Force bases in the U.S. on the East Coast. So, you're spending a lot of money, you're creating a lot of this material piled up, and it really does come into account. The next thing, besides looking at just say the surveys and where the channels are and how they are configured, that's kind of the geometry of things and partially the hydrodynamic. We also want to look at, what their dredge material management plan was for the port. What are they doing now? What systems are they do that they feel are efficient and ones that don't? At the time of this report in 2011, they were basically going to be out of material before now, right? They're looking at roughly 1 million cubic yards of maintenance dredging per year, and they had about 7.5 million cubic yards of capacity. So they had to go down that list of opportunities, and the list were to rate and what was generally adapted was raising the dikes in the facility. That's the easiest thing to do. The port controls those areas, they can do it. It's not the least expensive thing to do. It comes at a great cost, and there's a limit to how high you can go. They tried to look at using more of the ODMDS for disposal, and it just really is very cost prohibitive given the distance it is offshore. But it was one of the things they put into the list and tried to do more beneficial reuses and reducing dredging needs. But the last one's a great one. So if there's some way to keep the material from never having to be deposited in a berth or in a channel, to keep it moving through the system in a natural way, you could possibly accomplish that last one. So our scope of work with them, it is an active scope. We're looking to get the green light here, the NTP here pretty quickly. We're going to look at their entire budget. We're going to look at their federal responsibilities. We're going to look at the structures that they have out there and new infrastructure they might undertake. We're going to look at their dredging methodologies. So where the water injection dredge may be used near the berths to remove this light material that fits the geotech example of what you expect for a water injection dredge, there may be another use out here on this in this channel that is totally different than what you would have imagined. This area that you're seeing here in the swash zone, there is a lot of material that is sandier, not 100% sand, but fine sands to some silts and clays that builds up your prototypical channel waves, where the material kind of falls into a crest trough throughout the channel, mimicking what a beach template looks like. Their thought is, and what they do currently is they come out with a mechanical dredge, go to the crest of those areas where the shoaling is the greatest, scoop up the material, turn the mechanical dredge 180 degrees, and then drop the material outside. So they're just side casting it. Well, not surprisingly, some of that material is going to find its way back into the trough and keep feeding the system. It's kind of a I can't say it, but it's a recurring, ongoing burden that they're taking on by just moving the material that short of a distance. And really, environmentally, is it better to do that? If you were to fluidize this material instead, hit it with the water injection dredge at the crest, cause the finer material to wane, the sandier material to more settle back out, basically bed leveling. You would keep all of the sediments that you were concerned about and anything in the sediments at the bottom of the system. When you're doing it mechanically and lifting it and literally carrying it out of the water column, turning over the water column, and then releasing it on top of the water column, you're dispersing that material throughout the water column as much as you possibly can. It's almost harder to imagine how well you could do resuspension of that. So that's going to be another thing we look at. So we're really interested in getting out here and kicking the tires on this system and seeing where we can help the port get more efficient. So places where water injection dredges become a conversation, there are actually things happening going on there. I have this slide in twice, but that's good. So there is an active dredge in North Carolina. There is a scope to look at the dredging at Tampa. We mentioned Kansas. Kansas Water Office is very much interested in looking at these systems in reservoirs. Talked to the Georgia Port Authority. We've talked to the South Carolina Port Authority, talked to Maryland Port Authority, and have a conversation later this week with the Alabama State Port Authority. So we've had quite a few folks that were brought this information to. And now the final summary, and then I'll open it up for discussion. I'll be glad to, like I said, we could talk about some of those areas that we just listed. Let me put them back up there. If any of those are specifically of interest to you, that we are, engaging with those folks and looking at ways we might be helpful to them. So the takeaways. The key benefit of a water injection dredge is the fact that you're transporting this material through the water column. All that entails has to be understood, has to be described in full, but that is a huge benefit. And the ability to move material through the water is obviously less expensive. We just need to be very efficient at it, and there are things we'd have to do that. It's a rapidly evolving field. The concept of water injection dredging is probably 20, 25 years old when it really got used in Europe for the first time. And there are a lot of things, like we mentioned, the reservoir dredging. That's always been out there. People have always wanted to try that. It has never gotten to the point that's been used either internationally or within the US. Traditional dredging is often about moving and handling water. And I think a lot of folks don't think about that portion of it. Even if you bring it to one of these confined disposal areas, the water then exits that disposal area through decanting and through a weir system. So you're cycling that material. If you're concerned about something, you're cycling it through all this water, and you're taking it to a settling basin, and then you're releasing that water again. So that whole thought needs to be put in when you're comparing and contrasting these techniques. Understanding those water impacts really need to be something that's looked at. Site conditions, sediment, hydrodynamic forces, you need to know them very well. You need to make sure that you're feeding the system at the right time. You feed it at the wrong time, it's going to do the opposite of what you want. Technically feasible. And we've demonstrated that with North Carolina. We believe we'll be able to demonstrate in a lot of other ways. This is kind of a very feasible kind of alternative out there. Legal and regulatory concerns. The regulatory agencies in North Carolina, when this was brought to them, favored this technique. We're very interested in seeing this technique. Anything that kept them from having to permit the next large CDF on another swath of marsh somewhere or wherever they would have to put it was something they saw as a benefit. They wanted to see techniques more like this out there. So, there isn't an adversary in all conditions for regulatory. In a lot of cases, they can be big components of this, these kind of innovative techniques. And then the economics. We briefly showed that chart. Remember all those costs that I presented with you? Well, that's all the cost of just moving the sediment. That isn't the cost to build the next CDF. That isn't the cost to permit the offshore disposal. That isn't all these ancillary costs. If we really put the dollar amount that's the traditional dredging methods require into the picture, a lot of these innovative techniques are something that really should be looked at carefully. And there's dollars to do it because you have such a difference in the cost that you might be able to come up with. And with that, I'll finish and open up questions.
So there are some questions in the chat, Joe, and also,
Chat bar closed here. Let me pull my
yeah,
chat.
and if anybody has a question they want to ask out loud, just raise your hand, and I'll give you the ability to unmute so you can ask your question out loud.
So the first question that's here is about the mud motor and the sand engine methodologies. Do you have any challenges from permitting the concerns regarding flora and fauna? So let's go back to the mud motor real quick. So what had been happening out there with the mud motor is they were taking all this material offshore and disposing of it. And that was depleting the flora and fauna in this mud flat area to the left of your picture. So they were actually starving out the natural system by removing this material out of the normal flow of things. Reservoirs is a good example of that. We're discussing this with folks in the reservoirs. There are a lot of streams in the Midwest and other places in the US that are sediment starved. The flora and fauna are used to a flow of sediment coming down. It's been greatly depleted by having these reservoirs, which is catching and capturing this material. An extreme might be thinking about the Mississippi. When the billions of cubic yards that are taken out of the river and put into these holding areas that are accounted for, well, it's not surprised that some places down the end of the river at the delta are sediment starved. It's one of the things that it causes some of the losses that is happening in Louisiana. It's undeniable that removing sediment from the system in some places has a greater impact than others. So yes, the flora and fauna play a real big part of it. And so it's really important to understand, can you benefit it by doing this sort of thing? Is there some way, something that you can do that kickstarts the system in a positive manner and does it in a positive system? We talk about the sand engine here, because they're not coming out and mobilizing and demobilizing over and over, which really is it's like creating a parking lot. And they're out there doing the bulldozers, they're moving the sand, they're piling up the dunes, they're smoothing things off, they're moving on down with the material. Everything that's within that zone is highly impacted. If you do something like this instead, where you feed a larger portion of the system and let natural forces carry that material, everything that's already on that beach and that would react to sediment coming in is reacting to it in more natural ways, almost like a storm for them. So, the whole picture has to be evaluated. In a lot of cases, the systems are better if you're looking at some of these kind of systems than they were in the traditional methods we were looking at. Yes, the Seahawk. UNCW is the Seahawk. It's not the Osprey. Well, aren't Seahawks Ospreys? That's the next question. Is UNCW's mascot is a Seahawk, and a Seahawk, just like the Seahawk in Seattle, is really an Osprey. That's the bird. So, there you go. Just a sideline, not important to this conversation. The previous dredge that they had, the port had an old rinkety dredge, a hydraulic dredge that they had been using. They've been highly inefficient, long story. It was the Eagle, so it was sort of keeping with that nautical bird of prey theme. But anyway. So is the North Carolina State Port Authority commissioned with the first and only? It is not the first WID in the US. There have been, and there is a WID out there right now, Weeks Marine owns. They use it very infrequently. It is not the active method for removing material in any basin or port or anything of that nature. The water injection dredge in North Carolina is. It is their main dredging technique to keep their berths clear, to even keep the turning basin clear. So yeah, that's a good. I don't want to split hairs, but there have been other attempts to do something similar to this, but they haven't been done with anything within the last decade to 2 decades. I think the Weeks one is over 2 decades old, and so they're not efficient compared to the systems and the advances that have happened. They're more brute force. They're more like agitation dredges. And there are agitation dredges out there in the US. There's a large project happening in Louisiana right now where an agitation dredge is being used. And it rightfully makes sense for that place because the sedimentation is so high within the whole system that the agitating it into the whole water column is not a problem. But most of the ports are going to be similar to North Carolina where there it isn't advantageous to have that material all the way resuspended in the water column. It is better to fluidize it and have it move more naturally. So that's a real good question. And did I catch all of that? Have any other agencies or dredgers commissioned new widths? So we have talked that we gave you that list of folks out there. We're talking to a lot of folks. We do believe that we're going to see more folks bite the bullet and jump in there. One, the data from CORE will be a big part of it. I think once that data gets out there and people are able to say, now here's the third party, they reviewed things, here's what the data says. I think that's going to help a lot. I think there will be, I personally think that it'll be evaluated by a lot of other places. It just has such a cost benefit appeal to it and then doing things naturally. So good question, good question. That's what else we got. Are you assessing turbidity currents in your upcoming monitoring? Yes, so the density current is a turbidity current, but the density current is down there at the bottom. It's never more than what bed flow in a river would be. It can't be. Bed flow, maximized bed flow in a river is a non-material you can carry down in the river. So you'll never exceed those kind of backgrounds. You'll never exceed those kinds of things that the river does naturally. So you're doing and mimicking what the river does naturally. You're causing the material that had found its way down to there. It had to get there somewhere. It got there because the forces were strong enough to bring it. You're just causing that again to be refluidized back in the same force train and then carried on. So you know this is kicking the can down the stream, as you may. I've had people express, but you're kicking it down and dispersing the material over a larger natural area. You're taking it from a place where it's a concern to navigation, and you're releasing that concern. So yeah, that's a very good question, and it's so, for example, the person who asked the question mentions that trying to permanent innovative ideas like this in San Francisco Bay is very hard. San Francisco Bay is sediment starved, and that's one of the things that you know the natural system. A lot of folks forget what the natural system was before the man-made impacts came in here. So if you're looking at the reservoir downstream of a reservoir and you consider that the natural system, and you try to perpetuate that, well, then you have to keep that reservoir there. But what was it before? What would the flora and fauna really benefit from if that was the replicated system? And those are the questions that need to be asked. And they're not always easy questions. They're things that people have to decide. You have to come up with the preferences based on, you know, am I trying to replicate what it's been since the 1960s when the port was put here? Or am I trying to replicate the system that was there before the port was here? Or am I just trying to find the best thing I can do now? So that's another very good question. These are great questions. All right. In your opinion, what is the difference between WID and agitation dredge like Morgan City? So Morgan City specifically, that agitation dredge is not trying to fluidize the sediment, and it's dealing with there's quite a bit of sands in there. It's not very sandy, but there are some sands in there. It is just blasting that material back up into the whole water column and causing it to move forward. I think it's appropriate for what's happening in that area. Morgan City, Louisiana, the siltation in that area is very high. That's the natural normal background. That's why there's piling up material right there. So, you know, that type of use, similar to like the sand edge and mud motor, it makes sense sometimes to do agitation and plowing. That is the most efficient way to do it. It is the thing that gets the job done. I would wonder, I've always wondered about Morgan City. I just don't know enough. I haven't been able to delve into it. It's always been on my interest. If there was some other ways to train the currents or something that you could do where you could dissipate that amount of load that's coming in there some other way, right? You know, sometimes you wonder why you're trying to keep something open and free of siltation and you're working so hard, and maybe there's a fix in terms of structuring constraining the river, constriction dike, something that might be able to prevent that. But no, it's a good question. All right, so what else we got here? Do we have any more? That seems to be it. So I don't control the speakers. I can't turn them on and off and just let people ask questions. Are there any other questions out there that people want to pop it in the chat, or I don't know if
Yeah,
Sean,
again,
if you
you
can
just, if you
let
have any
people,
questions.
I don't know, what do you want to do, Sean?
Yeah, if you want to ask any questions out loud, if you'll just raise your hand, I can unmute you and you'll have the option to ask Joe your question directly.
I had a request for slides. Absolutely, I'll make them available. There's a white paper on where this talk happened. I'll make them available to COPRI and let them put that out there. And I'd love to talk to people if you have any more questions or anything you want to discuss on these kind of things. Be glad to do so. Hey, Sean, I couldn't hear you if you were talking earlier, and it could be me. Might be my
Nope,
problem.
sorry, it may have been me. I was just saying if anybody wanted to ask a question, raise their hand. I'd be happy to unmute them. And on the slides and access to Joe, if you just reach out to me at copri@asce.org, I'll be sure that your questions, I'll be sure that your questions get to Joe. And if there's not anything else, no more questions, we appreciate everybody coming and Joe for your time.
I thank everybody for your time.
Thanks a lot, Joe.